Learning Objective 5.5a and b are going to have us continue to factor, but with some special patterns will start to appear. But they work really the same way as normal factoring. So let's take a peek. So this is a binomial that they want us to factor. Now, we're not used to factoring binomials. We normally factor trinomials that have 3 terms. Well, this really does have a third term, but if you look at it in standard format, there's an x squared and it drops all the way to the number itself. The x term is actually not there. So what I'm going to actually do is show you the x term is there. It's disappeared basically, so it's 0x, and it's that. So now we're back to just factoring a basic trinomial. And if you want to factor into its 2 groups, x squared is going to equally break in x and x. And you need factors of negative 16 that go here and here, such that when you multiply these two, it'll add to 0. So for 16, there are a handful of factors. There's 16 and 1, 8 and 2, and 4 and 4. They have to multiply to negative 16, so someone in here has to be a negative sign. And you have to place them over here such that the 2 middle terms add to a 0x. Well, the key on this one is it does end up being the negative 4, 4 combo. Let me show you. So be negative 4 in x is negative 4x, x and positive 4 is 4x. Those two add to 0x, which gets us the middle term. And the special pattern here is this is called a perfect squared binomial because the numbers are the coefficients on the terms. For example, this is a 1 and this is a 16. 1 and 16 are numbers you can take square roots of and get nice whole number answers. So the square root of 1 is 1, the square root of 16 is 4. When that happens for factoring, the chances are when you have to find the right combination, they are going to be the perfect squared numbers. So in this case, the plus and the minus 4. Let's take a look at another one. So this one again in standard format has a y squared and then it jumps right to the final constant or number. There is no 0 or y term in the middle. I'm just going to put it there so we can get used to seeing that placeholder. And as you factor more, you tend to stop writing this middle term if it doesn't show up. You just get used to seeing this in this format and realizing there's no 0 term, but I'll put it there for now. So if we do the factoring of this trinomial, this y squared is just going to be y and y. And then factors of 4 are either going to be 4 and 1 or 2 and 2. But the key here is to kind of look at what they gave you. They gave us, in the original problem, we had a 4 and we had an 81. Those numbers you can actually take their square roots of and get nice integers. The square root of 4 is 2, the square root of 81 is 9. When that happens, odds are the combination you should use for the 4 is the 2 and the 2, and the combination for the 81 is the 9 and the 9. So let me show you how it comes into play. Again, we broke the y squared down, but let's break the 4 down and try the 2 and the 2. Let's break the negative 81 down and use the 2 9s that make 81. 1 does have to be negative though because the multiplication here is a negative answer. And we're going to put that here and here. And then when we multiply this and this, our middle term will be 0. So we'll do negative 9 and then plus 9, which will give us a negative 18y and a positive 18y, which cancel out. Therefore, we did find the correct answer. Now, here's another one. This is a trinomial already, so we can jump right into the factoring mode. And we're going to break up the h, which is first, the h squared, into a single h and h, so that's easy. And then the 100, which is the last term, will be the last one on each of these binomials. The problem with 100, there are a lot of factors that it could be. It could be 101, it could be 5 and 20, it could be 2 and 25, we could do 10 and 10, and so forth. So a lot of them to try. But again, the nice pattern is this. If the number in front of the x squared or h squared can become a nice square root, and if the last is a nice square root, odds are you're going to break them up to the nice square roots of those numbers. So the square root of 100 is 10. So they're saying try the 10-10 combo first. So I'm going to try plus 10 and plus 10, which multiply to 100, and we're trying to get this middle term of 20h. If you look at that, that'll be 10h and 10h, which was a great trick to use this time because we got the right answer right off the bat. Here's another one. This is a trinomial, so we can easily break this into two binomials like we're used to. But what I'm going to eyeball is this. The first number is a 16, the last one's a 25. The square root of 16 is 4, the square root of 25 is 5. So my gut instinct is to try 4 times 4 for 16 and 5 times 5 for 25. It may not work, but it's a good initial starting place. So let's do that. Let's break the 16g squared to the first terms. G squared becomes the g and g. 16, we said let's try 4 and 4. Then the last number is a 25, which is going to go here. And we decided let's try the plus 5 plus 5. We're trying to get the middle term of 40g. That's 20g, 20g, which adds to 40g. We got it.